Oh, dude. All right. So yeah, the Earth is a globe. All the objections they said don't make sense, like the fact that when you jump, you don't feel it moving. When you jump in a plane, you don't feel it moving. When you jump in a train, you don't feel it moving. The fact that you jump would not indicate its motion unless you don't understand that there's an atmosphere around you that's also moving. You feel changes in motion, not motion. For the other ones, there's curvature. There is curvature. So yes, we see curvature. We can prove curvature. Curvature's been proven. You can literally just bounce radio waves off the clouds and have them bounce back and forth. And you can calculate where they are. It's very, very easy, not difficult at all. Um, yeah, that's good. I'll just conclude there. Move on to like open discussion. How does that relate to the question? So, like, how does that relate to the question? Can go in a curve speed. That's perfectly fine. You still wouldn't feel it.
very long time, including going back to antiquity, where there were flat Earth cultures who were navigating successfully with their flat
Okay,
Earth views.
could you give me an example of a flat Earth culture that was capable of intercontinental sailing?
So the Scandinavian cultures, the Vikings were able to get to like Canada and to North America, parts of North America. I believe that there was some intercontinental sailing with the Chinese as well. And
Do you know how the Vikings sailed that? Do you know how did they use charts? Did they use instruments? Were they using calculations, or were they using a combination of dead reckoning and sun angles? Um,
I would reckon that they were probably using a mixture of various charts, positionings,
okay.
maybe coastal sailing as well, landmark navigation,
Do you know how
Celestial
they found
navigation.
reckoning.
Greenland? Do you
Was
know
that
how do you know how the Vikings found Greenland and found Canada?
how, how so?
It was it was by accident. They got caught in storms, blown off course, and they found themselves near these things. So it wasn't a matter of them navigating successfully into areas that they had never been before. They traveled accidentally into areas that they had never been before, and then a lot. The Antikythera mechanism dates from around 130 CE. And by that stage, we know for a fact that the Greeks were using spherical trigonometry in order to calculate eclipses, sun positions, and planetary positions. We have the textbooks that they wrote on these subjects. Also the claim, this is a slightly different topic, but the claim that the stars don't move is demonstrably false. We know from these old star charts that there has been precession of the equinoxes. Yes, Matthew?
Okay, I would like to address just a few things. First, you did lie when you said we didn't address that we were talking about the shape of the Earth. If you play back the video, the first material conditional I gave for the globe theory to be true was the curvature of the Earth. So I forgive you
I
for lying, right? Okay,
I didn't,
the
sir,
next example,
sir,
I want to talk
sir.
about. I
I
want to talk
object to
about.
that characterization.
All
I
right,
object
Play
maybe
straight
back
we
up
the
front.
had
video.
I
maybe we
never,
had a
Play
misunderstanding,
back the
everybody.
video.
So
I,
let's ask
Play
for
back
some
the video.
clarification. Let's ask
I
for
I
forgive
did
you.
not
clarification if that's the
accuse
case.
anyone of
You did.
lying. No, I
Yeah, you
didn't.
said we didn't
The
bring up the shape
term
of the
lie
Earth. That was
never
the first
crossed my
thing I
mouth,
said.
never left my mouth.
You said
We can
you're talking,
replay it.
you showed a Rubik's Cube and you said,
That
it doesn't matter if it's spinning. We're talking about the shape of it. And I was just in, I was like, that was the first thing I brought up was that we were talking about the shape,
Yes,
right?
and I didn't say you didn't. What I
Right.
said
But I mean,
was
yeah,
that your questions, what I said was that your questions about rotation and planes all have to do, are irrelevant to the shape. They're
rotation is
irrelevant to
irrelevant,
the,
right?
All right, just one
pardon?
second, Matthew.
How do you think,
All right,
can I,
go ahead, Matthew, and let's get
okay,
clarification.
really
But we got
quick.
to try
Yeah,
to
on globe
mitigate the
theory,
crosstalk.
really
I
quick,
did,
PhD Tony, the reason rotation would be important on a globe Earth is that would be the reason for having day and night. I'm not disrespecting you. It's not irrelevant.
but
And
these
and
are,
yeah, that's the
it
first
is
thing I brought up.
irrelevant.
But I do want to
A
change the
cube
All
is
subject
right, just
really
one
quick.
second, Tony. Let's let him finish,
I
and
want
I'll
to just kind of
cede the
like
floor to you entirely. Don't worry.
I just want to like really quick I want to go back to TJump, man. If someone jumped if someone jumped
yeah.
well, I want to get off my chest because yeah, you said what if someone jumped in a
Yeah,
plane, right?
yeah, yeah. Well, just one sec. Go ahead.
I just Dude, I was talking about the shape. Everything I mentioned was directly related. I don't care
Matthew,
if you
I
don't
think
All
care.
right.
I don't care if you don't care.
All right.
Everything I
We're gonna let TJump have a second here because he hasn't said anything in a hot minute. So go ahead, TJump.
all right. Play it back. Okay, if it's
All
about
right.
flat Earth, what do you think we're
All right.
talking about? How would we not stay on topic?
Hey,
How is it
all
right.
possible?
All right.
Right? Yes, because he said we weren't addressing the shape.
Okay,
Matthew, let me.
I think he already clarified what he had said in his intro, Matthew. So I do want to move on from this the idea
Yeah,
that he was lying in the intro.
yeah,
Maybe
it's
there, like I
like,
said, maybe there was a misunderstanding, but
yeah,
Nathan
my
had
under,
something he
yeah,
wanted to ask. So let's carry on and try to progress the conversation because we're
yeah,
getting
it's
into
like,
meta debate right now, and
Yeah,
how would it
it's
that
not
not be
useful.
about the
I
shape?
think he's just talking. There are various topics of this discussion, but focusing on the shape of the Earth is the most relevant, the primary in determining the shape of the Earth. We should talk about the shape of the Earth. Tony, I completely agree with you. I absolutely, you're being, I think, forthright and very on topic. Um, so I wanted to bring up that uh, you talk about the food and fuel and things for travel, going from location to location, and how I would explain how that is able to be done is that we are able to uh, we're able to gauge our
All right,
distance
now it's
traveled
over.
over the
Fucking
ground,
bullshit.
and then we're able to say, okay, if we're going to go this far, we're going to know we're going to need this much food to last this many crew members, and we're going to need to bring this kind of water. If they were able to know that they were by certain lands, they might have been there before. If you go onto one land and then some people are not too fond of you being there, maybe you continue to go on your voyage and you find another land and get out there. Are they being, I'm not sure if they're being attacked everywhere they go or anything like that, but if they can find resources on the lands that they settle at, but if they know the destination is um, so many thousands of miles away, then maybe they're already prepared for that, because going into an unknown open expanse of water, I think would be pretty difficult to reconcile how many resources you should bring along. So I would think maybe there's prior knowledge to the locations that they're going, and we are able to
10
topographically
seconds.
lay out
We
the
got to give him a
distance
chance.
of our ground coverage.
Okay, but one of the examples I gave was Shackleton sailing from Elephant Island to South Georgia, a journey that had never been made before, at a time of year that it had never been made before, in a vessel in which it had never been made before. So the claim that it's based entirely on experience is not true. And similarly, if you've got only two data points, which is your current position, which is what Bly had. Bly had his current position and he had his destination, and he had to calculate how much food he needed to make that destination. And he knew the distance and he got the distance right. We have his logbooks. We know how he calculated it. We know how he calculated it. Everything travels as though the Earth is spheroidal.
And just ask some about this.
Oh yeah, I'm listening. I'm watching what's going on. You're doing great, man.
Let's move
Okay.
into 1 minute
So
timed rounds for each side so that you
yeah,
guys can make sure you're bouncing back and you're not throwing too much stuff out there all at once. So 1 minute on the floor.
Just to continue with this with you, Tony, about so they knew the distance that they were going to a land but they didn't know where they were going. And it was the first time they had sailed using this craft, first time taking this route due to weather conditions, first time going to an unknown location, but they also knew it. I don't know if I'm misunderstanding you there. But if
So
they know the
no,
distance,
nobody had. So it's not the where they were going. Nobody had been. It was where they were. Nobody had been.
All
So
right, 30 seconds on that.
Nobody had been on Elephant Island before. They were trying to make Elephant Island to South Georgia. Nobody had made that journey before.
All right, another
So
30
they-
seconds
they
there,
were-
Nathan, with that clarification.
yeah, okay. So
Fine.
maybe I would suspect that if someone is in the dark about where they're at and then where they're trying to go, there would be very unknown variables there that would make navigation hard, so more difficult to really get an estimate of how far you're going to go. So maybe you're going to try to if you're in an unknown starting point, you know your end point, you still can't really gauge the distance, so you might just bring as many resources as you can,
5 seconds.
what you think might be reasonable, and hopefully get all the crewmen there well and able to enjoy the landfall. Ahoy!
Well,
Rambo.
1 minute for the globe side.
okay. So
You can
they
start.
did know where they were because they were able to make celestial observations of their latitude and longitude. So they knew where they were. It was just that nobody had tried to make this journey before. I don't know how to say this in a way that's going to clarify it more. They knew where they were. They knew where they needed to be. Nobody had made that journey before.
All right.
Okay, so they were taking a route that had
Just 1
not
second there,
been-
Nathan. I know Matthew had something he wanted to say.
Oh,
And
yeah,
I
sorry.
don't want him to forget his thought. I want to
Hey,
get everybody in
thank
here.
you,
So 1 minute,
James.
Matthew.
Thank you, James. Okay, Tony, I know what you're talking about. The people, they needed to make sure they had enough food and fuel to get to where they're going, right? They wanted to make the right calculations. But maybe you overlook that if they're sailing, their fuel is the wind. And if they're hungry, they could fish, man. They could cast their nets and get fish. So I don't know what you mean about they're going to be worried about all the food and fuel, because I mean, what kind of fuel do they need on a wind-powered craft? I don't mean to make you feel weird or anything. I know you're making a point, but
So where do they get fresh water from?
they just kicked oak barrels or whatever. That's probably the only thing they really needed. I mean, the
Okay,
other
so-
supplies, but
So they had to work out, you say that they can fish, but actually British sailors were pretty loath to eat fish. They considered it not person food.
I can understand that. But I mean,
The floor is Tony's right now. I'm sorry, Matthew.
But the fresh water is one of the resources that you most need, and that you can't find at sea. So they had to do a calculation of how far they were traveling, how long it would take them to get there, and how much resources they had. Now, I don't care whether or not you think they got the distance right. What I care about is that if you were on that ship, if you were captain of that ship,
15
you'd be
seconds.
dead because you have no way of making those calculations.
Right. Any thoughts there, Nathan or Matthew? You got 1 minute on your side.
Yeah, so if you were going to basically if you're gonna have a point, 2 points above the ground, you could essentially you could look up here at your zenith, and then you could determine the
Just 1 second.
distance
Nobody
and what
can
that
see
translates
that
to on the
yet.
ground coverage, and then find the location that you're going to, and you could then gauge the distance between the point where you're at and where you're going on the ground.
yeah, you're
Like a
talking
door
about
frame.
celestial navigation. You're talking about using the fixed stars to know your location on the non-rotating level Earth, right?
No,
That's exactly what I think it is. I mean, that's like a life
No,
and death gamble that,
it's
you know.
not.
Well, you say.
What I'm talking
Okay.
about is if you know your location here and you know where you need to get to there, how do you calculate the distance between them? And you drawing a diagram like that doesn't actually help, because without extremely precise chronology,
One second. Where's the Zoom? Yes, I know. Yes, I know I'm on mute. No, I think it's a complete waste of time. I'm not really interested in this specific topic. It's like flat earthers can do nothing. They've never built anything. They've never traveled anywhere. They never discovered anything because it doesn't work. It's a complete waste of time. The globe earthers do. We discover things. We make progress. We change the world. Until the flerfs can actually do something with their hypothesis that the world is flat, then they have nothing. They can do nothing. I don't care about their complaints, their opinions, their feelings, their thoughts mean nothing. Go do something. Build me something. Discover something. Go find the firmament. Do something. Your opinions are just not evidence. So I don't care about your word games.
Tony, you mentioned like they wouldn't know what star they're looking at. I'm not trying to make you look dumb, man, but there's something called constellation.
I do ask Tony as a qualifier to the premise of this. If they knew the location they were going, how did they know where it was? Don't they have to say the star should be above that location and that land, and then they look down and say that's where we're going to go towards? How did they know where the distant land was without using the sky? And so,
Okay. I'm going to explain this, and I'm going to use small words for you. My
Thanks.
point was not that they can't recognize stars. My point was that they cannot identify which stars are exactly azimuthal at their destination at a particular point in time. They would need an ephemeris, a specifically detailed ephemeris that would, and an extremely accurate chronometer. If we were doing this today, we could do this, yes, but just knowing
Was listening
I
to
think
what
that this is. I actually think that this is. I actually think that this is getting to be a waste of time, as the two of you don't know how celestial navigation works, and you don't know how these distance calculations work.
All right.
Yep.
Over to you,
Man,
fellas.
So I would like to actually introduce another data set.
Okay, just hold
Yeah,
that thought right there, Tony. We'll let them respond to what you just said there, and we'll let you introduce that in just one second. Matthew, you got something to say there, so I'm going to say
Yeah.
another 1 minute. Go
Matt,
ahead.
if you want to go, and then can we introduce a data set to advocate
I'll,
towards a
I'll just
flatter
want to
state?
go I just want to say something really quick if you want to finish that previous topic. But Tony, yeah, you mentioned they did use celestial navigation, so they had to know where they were on the Earth. And yeah, it's like, so they're using the stars. If they're at sea, what do you think they would use to navigate? Like, say they're out there for like, extended periods of time. The only thing they would have is the stars. Nothing to do with like calculating sphericity of any kind. Only the stars above. And I don't mean
Okay,
to prattle on or sound dumb or I'm just ignorant, but I just want to put that out there that the stars, that was important. Nothing about ball Earth. Nathan, I'm sorry for
so
taking the
why
time, man.
do the sailing manuals instruct people in spherical trigonometry?
Excuse me?
Why do sailing manuals instruct people in spherical trigonometry?
I mean, why would they perpetuate a lie? I don't know. People put all kinds of lies in books.
They're using so that there's a cyclical nature to the stars, cyclical patterns, and if you have the circles being made above us or around us, as far as what one model would claim or the other, you're using those circles and those trackable, predictable patterns that have been repeated throughout history and tracked throughout our logs of the stars. You're using those to be able to navigate, and if they had maps of the locations they were going, those could all be charted out star to star, ground location compared with the sky location of where objects are. And then they're able to navigate to this area that had been explored and already. So they knew where they were going. They knew the distances because they had traveled it and logged it.
Except we have their logbooks and we can tell that that isn't what they did. We know how they did this calculation. It wasn't in the way you're suggesting.
Okay, so if they had calculations in their logs to the distance of the port that they were going to, and this was that someone had already been there, but they themselves had not, they are going to calculate the distance that they already had a map to the location.
No, they did not have. All they had was the coordinates of the location.
They had the coordinates.
Yes.
And then they had to determine the distance to that coordinate.
Yes.
So,
and they didn't do it in the way you're suggesting. But look, it is clear to me that you guys don't know what an ephemeris is or why it's useful, why it would be necessary for the calculation that you're discussing. So let's move on to another data set. Okay.
Okay. Maybe I'll ask you later about what that device is, but okay, I have a data set if I could bring it up. I am curious.
Just 1 second there, Nathan. We're just if you can hold on to yours now, I'm just going to ask you to hold on to yours. We're going to let Tony do his first. So
okay.
Tony, go ahead.
All right, I just need to share my screen. Is that okay?
Sure thing.
Okay. All right, imagine a sphere. Imagine that there's some sort of vibration at the top of the sphere. We would expect that vibration to spread out like this. And if you look across to the left, that's the top view. It's spreading out like a circle. Now it moves into the other hemisphere. If you look to the right into the bottom view, you'll see that it starts converging on the other pole like a circle. Now let's look at an actual earthquake. This is the Macquarie Rise earthquake of 2004. The epicenter is that red star. The blue circles are the most recent seismic stations to receive it. If we run forward in time, we can see that the signal moves out in a roughly circular fashion. We can see also that it has made it to the far side of Antarctica without going through the northern hemisphere in any sense. If you look at the flat Earth model on the right, that doesn't make any sense. But we're going to run through in time, and you can see the circularity of this wavefront spreading out. as it does so. And if you look on the right on the flat Earth model, you can see the circular pattern. Let me just rewind it a little bit so that you can see that better. You can see on the right-hand panel, you can see the circular convergence on the point opposite on the side of the Earth. So we made a prediction about how earthquakes should behave. We went out, we looked at some earthquake data, we got an exact match. And again, there is no flat Earth model for this. Here is a model versus prediction. The model are the solid lines. The predictions are, the observations are the dots. So the model predictions are the solid lines. You will observe that as the arrivals get later, get further and further away, the wave seems to be traveling faster. Why is that? Well, on a flat Earth, there's no explanation for that, but on a spherical Earth, there is. The wave is traveling less distance, and it's doing it at greater depth where there is higher velocity. So we have observations, we have a model, we can predict, and this is 1 million predictions. Give
I'll
me
give you
any
30
earthquake,
seconds.
give me its depth, give me its origin. I can predict the waveform arrival times for you. You have nothing.
All right.
Matt,
Thank you
I'm
so
gonna
much
I'm gonna
for
jump in real
that.
quick on this one.
Yeah, we'll give
So,
you each a minute.
Okay, Tony, can I just ask a real quick question? I've heard that there is some difficulty with waves traveling through Antarctica, the continent. Is that any sort of accurate? Just as a qualifier.
Well, there are
Okay, so how I would try to explain, and one thing about and even this can relate with the distances on the ground and everything. Flat Earth, we claim to use those kinds of maps, like the azimuthal equidistant map and everything, are more for to get constant. That you show that you get a mark over here. And I think what could happen is you have the waves going out, and then they're going to angle, and everything is going to
15 seconds.
eventually converge antipodal, and then it's going to go back and bounce. And this is not supposed to be some sort of shape, like weird shape or nothing. I'm not into the universal stars and all that.
Why does the wave not propagate across the center of your disk?
TJump, you were making some expressions there. Do you have anything to add?
I've been messing with my audio, trying to get my audio to work where I can send my audio to my stream while I play video games. I just got it to work, which is great. So what I would say is that what Tony said about earthquakes is a great example. So if there's an earthquake in Malaysia, he can predict where the earthquake's going to go, to which city, where, everywhere, get it right 100% of the time. So like if the globe is correct and there's an earthquake here, you'll get an equidistant circle. It'll go to all the places. And if you get an earthquake in every different continent, they'll connect in some way. It'll always be some equidistant to some other one. But if the world's flat, that won't be the case. There'll be an earthquake in some part of the very far right, and it'll never touch the very far left, or it'll be very, very far away. But we don't see that. Never, ever in the history of ever. It doesn't happen. When there's an earthquake, it'll go equally in every direction and hit every continent equally in every direction. It's never the case that there's just one area where it just never gets to. It doesn't happen. So Tony's example of earthquakes is great, because if earthquakes happen on a round sphere and they happen regularly in every different location, then we can prove for a fact the world must be round. That's it. Game over. You lose. Because if it's flat, that gives a completely different spread of the way earthquakes will spread, the vibrational spread. He's debunked you. Like, what? How do you explain the rate and location of where the expansion of these earthquakes goes to, and why does it always go equidistantly to every location?
All right, over to you, Matthew.
Okay, to answer that simple thing, I mean, that's funny you say it's debunked and game over, right? Time to go home, right?
Yep.
Yep.
Hey, anyways, about the cartoon that Tony was showing, on the one side, it was the azimuthal equidistant map, which is useful because the distances are correct. Okay. Now, the one you showed on the left side it's even worse than the globe. Like if you look back on the graphic you showed, it's the southern azimuthal, which is totally wrong. None of those distances are correct, like in the northern hemisphere. So what you showed actually is so incorrect. It's worse than globe. Okay. Now, I appreciate the cartoons, but there is that pesky ice wall. So you see how the cartoon energy was bouncing away? That's probably what it did. I would love to go see it. I'm not rich enough to go pay 20 grand to go down there, but if I would like to. But maybe that's why the things bounced a certain way.
Maybe is not science,
I
mate.
love you, man. I love you, Tony.
Did you have anything to respond with there,
Yes,
TJump? We haven't heard
I have
from you.
several things to
much.
respond to.
Or
Saying
Tony, I guess, yeah,
maybe,
go ahead.
or saying maybe, or possibly, or whatever. We've got a model. We've got a prediction. The model, we've got a model. We've got a prediction from that model, and we've got observations. The model and the observations match. That is validation of the model. You can't just say, well, maybe there exists a model. I don't have it, of course. I can't do any predictions, but maybe there's a model that matches up. That isn't science. That isn't even a basis for a scientific conclusion. Furthermore, your problem is even worse than that, because it turns out that there are seismic waves that go from the point of origin. I actually have another display. May I share my screen again?
Sure thing. Just let me know when you're ready.
Yep, just a second.
You are good to go.
Okay, here we're looking on the left. We've got an earthquake occurring at the top. We've got wave fronts. One's going out to the right, one's going out to the bottom. These are surface waves, so they travel around the circumference. So they get to the receiver, bang, that's the R1 wave. They continue going round. They go into the opposite hemisphere, and now they come back and they get to the receiver from the other direction. So if there's a receiver south of our current receiver, they come back, bang, that's R2. Now we get R3, which occurs very close after the first one. So these waves go round and round and round. If you've got a large enough, shallow enough earthquake, you'll get R4. This also happens with atmospheric pressure waves. For instance, the Tonga Tapa eruption. This is the air pressure wave around it. You can see it spreading out from Tonga Tapu. This is it 73 hours later after it's made multiple circuits of the, and this is observational data. You can hold your hands all you like, Matthew. This is real observational data, and I have visualized it for you. I have turned it into a graphic. Fine, but you don't get to pretend that the data doesn't exist.
May I respond?
Sure thing. Over to you.
Hey, Tony, man, your cartoons make me laugh more than Looney Tunes, dude.
All right.
Dude, I'll tell you this, okay? Really, may I have just a little time to speak and eloquate? Okay, computer programs don't mean anything. I'll tell you why. Someone probably make a computer program app on my phone. They could show me Pokemon in my front yard. With my eyes, I don't see I don't see Pikachu. I don't see Charmander or Ekans. But the phone, someone can show me on their device. Look at this proof. It's right there. Pikachu. And with my
You're
eyes,
just saying I'm lying to
with
you.
my God-given senses, the computer program can say anything it wants. The numbers, you could do any numbers you want. But it's like, dude, I love your cartoons. No, I love your cartoons. I love them. It's funnier than Looney Tunes.
You're saying that the data doesn't support these presentations.
I'm saying the data can obviously be manipulated. I mean,
obviously, how obviously? What is your evidence for supporting that claim?
Dude,
you just
use the cartoon.
claim. What's your evidence?
That's my evidence. If I show you a cartoon of Pikachu, that doesn't mean he's hanging out with me.
God. Oh my god. So wait,
No.
can I
Hey,
interrupt for a
sorry to
second?
tell you, dude.
The
get
cartoon,
hypnotized.
the
All right,
to be fair,
cartoon doesn't
TJump
matter.
has said the least, so let's give the floor to
The
TJ.
cartoon is a picture to help you understand the argument. The cartoon is not relevant to the argument. So the cartoon shows a picture of a globe, and if there's an earthquake in one location, it'll spread out in a circle, right? That's just showing you that. If we expect this to happen, like if the world's a globe, and the globe predicts that certain cities are in certain locations on a globe model, then we can predict that if an earthquake happens here, it'll hit this city and this city and this city, the ones that are equidistant in every direction at the same time. That's all the cartoon is showing. And that has happened. That literally has happened. There was an earthquake in a location. We know the buildings got fallen, and we can test what time was the earthquake felt in a different city. And we can say, hey, there are people there. They have their phones. Like, hey, we were feeling the earthquake at this time. And we can say, oh, look, this is the time it happened. Here's how far away it is. Here's how the thing spread. Now, if it's a globe, it's a ball, and the earthquakes happen all over the ball, everywhere, all over the ball, then we can measure how far away every city is. It's going to come a very, very strange shape. If the world's flat, there are earthquakes all over the ball, it'll be different. It'll be two different measurements with different numbers for when the earthquake reaches here and here and here and here for each different earthquake. It's triangulation, different numbers. Guess what? The globe numbers are right, Flurf numbers wrong. So the cartoon is just showing you the facts that have been proven not by a cartoon, but by the actual data we have of when the earthquake happens and when it gets to the other cities everywhere else around the world. So the cartoon isn't the evidence. That's just a picture to show you why you're dumb.
Okay.
I think what
thank you.
Let's let Nathan in here right quick, Matthew. Just
I think what Tony was showing there was the data collected from detectors of the seismic waves, and then
Cell phones.
What he had done is he graphed out where those detectors were and when they went off. And Anthony, I was going to ask you if you could, and I do believe we have the ability to detect these things, that is observational data, empirical data that they've measured. Would you be able to show like, I think it was around 190, the slide? If you could show around there. I was just curious about one thing, but I do think that you would get sort of like if you dropped, because if I think that these waves would travel, we could kind of maybe try to use fluid dynamics to understand the properties of how these waves would move about. And I think if you drop something into like a tub, like if you drop a ball into a tub of water, the waves that are going to go out closest to the sides would bounce and then go in a direction from there. And then the waves that are traveling out the furthest before they hit a wall, they're going to keep going until they hit their wall and then bounce from there. And so I'm curious here. This is on the right side here. What's that?
So, okay, except that we can prove that that isn't what's happening, right? So I've got another presentation. It should surprise no one.
all right, I'll give you 2 minutes on the floor there if you want to show something up there. But before we move on, Nathan, you had some closing thoughts on what we were just talking about?
Yeah, with where Anthony was showing there with the epicenter, I just wanted to make note that you had pointed out that there was a detection that was about on the opposite side of the flat Earth model, which would be further distance on a globe than points that are closer to. There weren't stars. If you were just looking at that map on your computer screen, on the top half of that map, there weren't any detections that were closer to where the epicenter is on the Antarctic coastline.
Let me show that again, because you missed them.
All right. And this is before you want to make the next point here, because we will eventually go into the Q&A, but if we want to bring up a new topic, that's totally fine by me. I don't mind if we go a little bit longer. That's cool.
Okay, so you're talking about here?
Yeah, so you could maybe run it forward a little further. Okay, so like say right there, like right around this area. So right now you're getting a reading that is around that 30 mark at the bottom there. That's on that ring. But now if you look straight up from the star. You have those 2 red dots on the coastline of Antarctica, but there is nothing kind of over towards that 150 area, which on a globe with Antarctica the shape that it's claimed to be, that would be a closer location. They appear
Yes,
to
it would
spread
be a
out
closer
across
location, but there's no seismometer there. So we are constrained by where the instruments are. So the fact that there's no circle there is an indicator that there's no instrument there, or at least no instrument that showed up in this data search. So it's not the fact that the wave didn't make it there, it's the fact that there's no instrument to detect it.
Okay.
So but we can refute the reflection argument. Just give me a moment. Need to find the right one.
A1. Are we moving into your next point now? I just had to check on the kid out there.
I've just found it. Let me just go. Because we know actually what happens when a circular wave reflects off a circular obstruction. Let me just share once more.
Yeah, you're all ready. We're still ready to do the share.
Now you can find videos of this on YouTube, people with shadow tanks doing this experiment. The wave starts at the purple star, it spreads out, it hits the circular edge. Now what happens when it reflects is this. It turns into a straight line and sweeps back along. So it doesn't go out across it doesn't go around the edge of the disc. And as I say, you can go onto YouTube, you can look up circular wave, circular obstruction, and you can see what happens for yourself. So no, your reflection mechanism does not make sense and it does not explain the data.
So I would want to contest that what you're showing here is not an accurate representation of what an Earth would be, because this looks like a uniform, homogeneous, one material type of circle that the simulation is being run through, as opposed to has this model been done with various densities of medium within the ground, within the water? Have these wave motions been tracked in different density mediums?
Yes, there have been attempts to make flat Earth models, flat Earth seismic models that can work on a regional scale. They don't. I can show you the papers. I've got them here. Snokes and La 2001, Bai et al 2017 investigated on what length scale you actually need sphericity in order to match the observations, and the length scale is 150 to 180 kilometers. So after the wave has traveled 180 kilometers, there is no way to have a flat Earth model that matches the observations. Yes, we have looked at this, and if you're going to say that's wrong, you need to come up with one. So you need to come up with a model. This is what I said about earlier. If you can't lift the weight, you lose, right? We're in a weightlifting competition now, and you haven't even attempted to lift the weight. You haven't made an effort. And laughing and saying, oh, yeah, we can, is not going to cut it. They don't hand out Olympic medals for saying, yeah, sure, I could do that. No problem. Do it. And you'll find out that it's just not possible. My PhD was in adapting flat Earth seismic models to model viscoelastic relaxation. I know about flat Earth seismic models. I'm an expert in them. They don't work on long length scales. It's that simple. And you can dispute it. You can say you're wrong.
You just say you're a flat Earth doctor?
I
don't mean to interrupt you. I'm sorry, but what did you say? You flat Earth seismology, and what did you do with it? You took it and put it in some kind of model that maybe put it onto a ball coordinate system? Did you say? I'm not understanding it.
Yeah, clearly. What I said was part of my PhD thesis was adapting a flat Earth seismic model into modeling viscoelastic deformation.
Viscoelastic deformation?
Yes. So deformation that has both a viscous and an elastic component, like a Maxwell solid.
So what's the purpose that what you studied was called flat Earth? And
No,
I'm not getting it.
what I studied was high resolution modeling of glacial isostatic adjustment. So the way the Earth deforms under heavy weights like large ice sheets or large sediment loads or volcanoes.
Earth science.
Yes.
Okay. Yeah,
So,
you had me going for a loop first. I thought you were saying like you take the flat Earth seismic data and you do something you change it somehow.
no, you don't.
So,
yes.
Tony, I got just a quick question. When you're trying to make flat Earth models of seismic activity, are you using the data that we have according to like our current ability to record and detect things, and then we're taking those data sets and trying to put them onto a flat Earth model?
Yes.
So I would ask if there is any sort of transform going on with, well, let's say the military accuracy of data compared to what we get that might have gone through a transformation equation, Lorentz transformation or anything like that, that maybe that it would be difficult to put the data to a to the slightly more precise or however much more accurate true representation of the Earth, because we are not given the actual distances or anything like that.
It's just a matter of time and location. That's all that we're getting here. All that we have is the time at which the wave function is a function of time at various locations. There's no
Okay, so they're going off of
transformation,
the distances that we have recorded.
well,
A is
no
such distance from B.
locations. We're going off the locations for the seismic instruments that we have.
Okay.
Right.
And if I could real quick just address, and then I'll kick it back to you. But I do, so I think why there are not like flat Earth seismologists right now is because when you go through the academic schooling system, you are trained using globe models, globe numbers, and so the people who are going into these fields are taught certain methodologies and practices that involve using certain coordinates, certain measurements, and so I think that there's a reason that there are it's the lens that things go through.
Allow me to rephrase what you just said. There is a reason why everybody who has been highly trained in seismology thinks that the Earth is round, and that's because the data overwhelmingly supports it. That's the reason there are no flat Earth seismologists, is because the data doesn't support your position and you don't have any valid models that match our observational data. If you did, and this is the thing, if you want flat Earth to be taken seriously, you know that formula for the spherical distance that I showed you at the beginning of my presentation. Find me 2 points on Earth's surface where that's wrong, any two, because all of the pairs of points that we've applied it to, we get the right answer. So just show me where the spherical model is wrong. Show me how it's wrong, and I will start believing you. I will start taking you seriously. Okay, but that's what you've got to do. You can't just say, well, maybe there's some way that it can work. Show me, tell me, prove it to me, right? And you've got to do this, and you are sort of on a hiding to nothing because none of you have the technical expertise to really process seismic data, and I understand that's an obstruction. But if that's the case, maybe listen to the people who do. It's just like flying a plane. You may not be able to fly a plane, but you trust a pilot to do it for you.
Yes. Geodesics is y'all, what Tony does is very complicated mathematics. It's very involved, very intensive. I've heard that geodesics is the most complicated form of mathematics that academia offers to learn and study. So it's very high level, very in-depth mathematics, and I do agree with that. But I would think maybe that, so like the USGS uses a flat Earth model as their logo, and they are the ones that do have contained the most accurate data. And so I would think that what coordinate system we use, if we're looking at certain flat Earth models that are shown like the azimuthal equidistant map, though that is claimed to be latitudinally and longitudinally accurate, and so those coordinates would match up. And then if you ascribe those to a globe with that data set, you're going to be using real land-based coordinates that are latitude, longitude correct, and then you could apply them. The coordinates are there regardless if you want to say that they're sphere or triangle or square shape. The coordinates are latitude X, longitude Y, and then they apply it, do very complex math, and then get a data set.
May I share again, because I think you missed a point in my original presentation?
Sure, I've gotten used to these discussions involving a lot of screen sharing, so go for it, Tony.
Okay.
There's no worry at all.
Thank you for that. I'll just close that. That's my rotation presentation, which is a completely different thing. But okay, so if you remember my argument from down here, right? So the flat Earth model tells us that as you go south, the distance between points of a given longitude must increase. Okay, but here we have points that are in the northern hemisphere and at the same latitude, and points that are in the southern hemisphere and at the same latitude. And we can use the rail track length between them because the rail tracks are mostly east-west. So we can just divide those rail track lengths by the number of degrees longitude difference, and we can get the difference. And over here we see that in the northern hemisphere, the distance along this train track is longer per degree longitude than it is in the southern hemisphere. That's the opposite of what should be happening. A degree longitude in the northern hemisphere should be shorter than it is in the southern hemisphere. And as I said in my presentation, we can go even further south. Sorry, seem to have lost that. Element. But but if we go to Argentina, we can see that the unit size per degree longitude gets even shorter, down to 93.5 kilometers. So we see that degrees in longitude get narrower as you go to the pole. They don't get broader. So, you know, if we accept your map, if we accept what it says, which is that degrees longitude should be extending, we can prove that that's wrong. We've got railway lines. They can be measured. They can be walked. People travel between these cities. We know how far it is. They have GPS units on them. They record their positions. So, you know, this argument that you've got that the azimuthal equidistant northern hemisphere map works, it doesn't. It doesn't.
When you were showing that, just curious for clarification, when you were showing that the railroad tracks of the Southeast United States and Australia, Florida and Australia, the point of emphasis there was those points between those dots added onto those railways, I believe the white and red dots. So so that it was actually a wider span in the north. And I've heard Neil Tyson say that the Earth is actually bigger in the southern hemisphere. So wouldn't that conflate with the globe as well? And no. I would agree. If what's that?
No.
Okay.
This pear-shaped thing that you're all very keen on.
It's very slight.
It's a very modest influence. You would not see it. You know, you could look at the Earth. You would not see it if you were on a satellite. You need very precise measurements in order to detect it, and certainly more precise than a railway line. Okay, railway lines are good. I mean, they're a fixed physical thing whose length we can measure, but they're not precise measurement devices.
And for the railway, is there the stretch of land that they took from Australia and the stretch of land that they took from Florida, if you looked at both of them side by side, they're going to have equal topography, amounts of variation in their elevation. So
Yeah,
those are,
roughly, yes.
oh, okay. And I would, so then I would think if we are using, especially like,
But that actually argues against you, right? Okay, let's assume that there is lots of up and down, and let's assume that there is lots of sides and side. The track length is still less than the flat Earth estimate, right? So the flat Earth estimate is the flat Earth requirement there is much, much longer than what is observed. Okay, the spheroidal Earth estimate is always shorter than what's observed. Okay, which is consistent with there being topography and little wiggles side to side. But but you need that line to be as straight as possible, and in some cases 3 times as long, in order to match the observations, and that just isn't true.
So I'm curious because you're saying that the rail length distance isn't what it should be on a flat Earth, but I have yet to, and I'll take note that what was shown there for the maps were flat map portrayals of these land masses. But I would think that there would be, because I don't have a 100% accurate map of all of the continental land masses of the flat Earth, to assume the shape of Australia, the width of it, or what dimensions are on land, all we would be able to tell is by the length of the railroad tracks themselves. That would be our only kind of tangible ruler, because anything else would kind of be like a rubber ruler.
So what you're saying is that it doesn't matter that the data disagrees with your model.
Wow.
Your model, the fact that the data contradicts your model doesn't matter. That's not a concern for you.
Well, I would not say that's my position. I would say if in Florida 1 and position 1 and Florida position 2 requires X amount of track to be laid down, no matter how much up and down or side to side meandering it has to go through to get there, I will claim it's going to take that much track to get there based on the path that they took to connect those 2 distances, and the amount of track would be the same in Australia.
And that distance is always consistent with the spherical distance formula. The amount of track you need, the amount of submarine cable you need, the amount of air fuel you need is always consistent with the spheroidal distance formula. And it's never, well, it's not often consistent with the flat Earth formula. It can be for some specific locations, but it's not where our formula works all the time. And if that's the case, that means that Earth has to be a sphere.
But didn't you say that the globe predictions tend to be under the actual amount of track used?
Yes, because the tracks aren't perfectly straight.
And yeah, and there's winding, and it's not taking the straightest route possible to get there.
Yeah, that's right. So the spheroidal Earth distance calculation is the shortest path possible. The train line isn't. But even allowing for that, you in the Australian example, you've got 1,280 kilometres of track, and the spheroidal distance estimate is 1,242 kilometres. So it's accurate to within within a few percent. So I'd say that that's pretty good validation for the spheroidal distance formula. It's and this is the thing that I'm trying to get. Whenever this is what I think the criteria should be, and I think that I agree with you guys that it's okay to ask questions. I agree with you guys that a lot of people think they know why the Earth is flat, well, why the Earth is spheroidal or flat, but they don't actually look at the data. But if we look at the data and compare the models impartially, the spheroidal model performs better, and that validates. Go on, Matt.
I already demonstrated with my opening statement that the globe theory is a contradiction, so therefore it cannot be a globe. Any computations you make, data, computer programs, yes, you could make many beautiful mathematical equations. You could give me the equations about like how much Santa Claus weighs and how much cookies and milk he gets on Christmas and how many eggs the Easter Bunny lays and what color the eggs are that the
How is
Easter
it a
Bunny lays,
contradiction?
the probability of the
How is
green
it?
and blue.
How is it a contradiction?
Oh, the globe theory?
Yes.
Where would you like listen to my opening statement?
Your opening
Let's do it
statement was
again.
garbage. Give me an example. How is it a contradiction?
In what way? In what way?
How is
shape
it a
of the Earth?
contradiction?
Okay, the globe theory suggests that the Earth actually curves.
How is that a contradiction?
Okay, let me illuminate this for you, TJump. I'm not trying to be weird, but if the theory is saying something's going to happen, and then we put that theory to test and we look in reality, and the falls apart, like when we don't see any curvature over 1 mile, 10 miles, 100 miles, and it's non-existent. Therefore, to assert that there is curvature on the Earth is a contradiction. Therefore, the first mandatory conditional for there to be a globe is not there. Therefore, if the first mandatory conditional is not there, and we can prove that it's not there, that means it's a contradictory statement.
No, that is literally not what the word contradiction means. You need to Google what the
Well,
word contradiction means.
Okay, we could bring up the definition and then like put it into practice and see if the definition of contradiction can be applied to curvature and globe theory.
All right, Dr. Tony, you had some thoughts there.
I did have some thoughts there. One, you didn't present any data. You didn't present any observational data in your opening, and you haven't presented any observational data in the entire discussion to date. So the claim that you did is not true. I maintain the position that you see exactly as much curvature as would be expected given atmospheric conditions and your position. Always, under any circumstances, and your claim to the contrary requires demonstration, and you have failed to produce any observational evidence whatsoever supporting your point. So your claim to have contradicted the globe is simply an assertion and without evidence and can be dismissed instantly.
May I respond? I gave all kinds of info. I gave you info about how much curvature there should be over 1, 10, and 100 miles. I gave you the information about the alleged rotation of the Earth, which wasn't there. I gave you the information about the alleged tilt of the Earth, which wasn't there. I gave you information about the non-existent gravity. I gave you information about that. If you want observational data, my testimony is with my eyes at ground level, I could see for many, many, many miles. That's my personal testimonial observational data. When I go to a higher elevation, like a tall building or a hill, I can see there is no curvature. And I'm not talking about between 2 points. I'm talking about if I'm in the hills and I can see Santa Ana, Anaheim, Buena Park, right? And then I can see more than 20 miles, almost 25 miles away, and I can identify Long Beach with my eyes. And I can see there is no curvature, not just between 2 points, but over surface area. Now, I mean, I don't know if you know the locations I'm talking about. I don't know if you're familiar with Southern California, but it's like from Hollywood to Disneyland. It's flat, 100% flat.
Can you see radio waves?
Can I see them? No, I could hear them. I'm detective.
So based on your evidence, based on the fact that you can't see them, therefore radio waves don't exist.
Dude, we could prove radio waves exist.
We can prove the curvature.
You say that, but I can't. I mean, I don't see it. I can hear radio.
But we just established that the fact that you don't see something isn't evidence it doesn't exist.
I could turn
We
on my
just
radio and hear it.
established that for radio waves.
All right.
We can establish it for X waves. We can establish it for atoms. Like, I listened to you prattle meaninglessly for about 5 minutes. So stop interrupting me. We just demonstrated that you not being able to see something is not evidence that it doesn't exist. So you claiming I don't see it, therefore it doesn't exist, is not evidence. It's not an argument.
Meg, hey, dude, I told you I could listen to radio waves, and then yeah, they get blocked. Signals get blocked, so we could prove that radio waves exist. But I mean, you want to say curvature exists? That means, honestly, that is like you're lying to me, saying we could see curvature. And dude, I'm sorry to tell you, PhD Tony, there is no curvature on the Earth over 1 mile, 10 miles, 100 miles.
How do you not understand? Wait, stop.
Must we listen to this guy just repeat himself?
Let's just give for a second there, Tony. Just 1 second.
Okay.
TJump, you're making a lot of noises that should be reserved for the 18+ sections. So like, what's going on, buddy? What's
the stupid of everything Matthew is unable to understand breaks my brain. So Tony was making a very simple point. Matthew's argument was dumb, was just stupid, because he said, I don't see curvature, therefore there is no curvature. Then Tony made a very clear point. Do you see radio waves? Like, no. Matthew admitted he does not see radio waves. So if Matthew's first argument actually worked, then by virtue of the fact he can't see it, it must not exist. So since he can't see radio waves, they must not exist. Since that argument fails in the case of radio waves, even if you can't see them, they might still be there. Then it also fails in the case of the curvature. Even if you don't see it, it could still be there, which debunks his own argument. That was the full point of Tony's argument, and Matthew just completely did not understand that. And it was so simple. It's so simple.
So
I don't think we're going to forget this one, Matthew. Let's just let Nathan in right quick.
Can I
don't think you'll forget, though.
If I can jump in here real quick.
Go ahead. I'm giving the floor to Nathan.
If I could share my screen here real quick.
Go ahead.
So what I have here, so let's take this claim of and I'll try to be as clear as I can with this. So let's take this claim of, is there curvature that we can detect? Say I'm skeptical that there's curvature. So we can look at something like bottom-up disappearance, and we could say that is more inferential towards there being curvature, because something would go down a physical dip, and then only part of it would be visible because of the curvature. So so if we look here, this is on so now a flat surface needs to be able to show what looks like bottom-up disappearance, what looks like curvature, using realistic natural variables that we would expect to find if we were measuring for them out in the real world, in the shared reality. So this here is a known flat surface, and using temperature variation, you'll watch as the bottom of taller objects, and then things that are shorter inherently are all removed because of this controlled variable. And so this is a recreation of what should support a globe, but it's recreated on a known flat surface. So now we can look out, because this is what looks like a curved observation in reality. Now we can look to what would be something that would show a flat observation of reality, which would be these lights, which are all 1 foot high and observed from a viewer height of under 1 foot. They're 5, 6, 7, 8 miles away, and they appear in a line. So if you graph them out, so this looks like flat. So now the globe, which is claiming contour, has to be able to recreate a demonstration where we can have realistic variables. If you want to call it refraction, take any refraction you want, control it for a variable in a scaled experiment, and then repeat it and show to scale that a curvature rate would be able to look flat, because these are linear space lights that are exponentially curving further than each one than the last. So you would need to show that this can appear on a known curved surface to scale with the controlled variables, and it has yet to be done I've tried asking a smorgasbord of times to a plethora of people, and I've yet to see this recreated on a known curved surface. Okay, yeah, that's
Thanks for ending the share there.
Okay, may I have one last thing before I go, or if we go to the next topic? I just want to say about, yeah, we can't see radio waves, but we can know they exist by, sending them and receiving them. My point about the curvature is like, how would we determine there is curvature if it was not seeing and recognizing locations at further distances?
I'm glad you answered. I'm glad you asked that
Just one
question.
second there, Tony. Just one second, Tony.
I'll
I'll give you one full minute after he's finished his point here. Go ahead, Matthew.
But that was just my point, is that, yeah, we can detect and send radio waves, and then the curvature, the best way I could think of that's actually real, not a computer program or a cartoon, is to identify locations at long distances. That was my point earlier about naming all those cities that I have recorded. I should have had a bunch of things. You guys check out my YouTube channel, right? But yeah, it's no curvature. We don't see it. There, to say there is, it's a lie. To say there is.
Okay, we're gonna give the floor over to Tony here. Just
okay. That's the third time in this debate you've just called me a liar. Please don't do that. The other point I would raise is, why can't I see Everest? If the Earth is flat, Everest is 10 kilometers tall. Why the hell can't I see it? So you keep on saying there's no evidence of curve. The fact that I can't see Everest is evidence of a curve. The fact that radars have horizons is evidence of a curve. If the Earth was flat, radars wouldn't have horizons. The fact that a degree of longitude covers different distances at different distances from the equator, and that it decreases as you move towards the poles, is evidence of curvature. All of this stuff is evidence of curvature. To claim that there's no evidence of curvature is nonsense.
That was perfect. That was actually a perfect minute. My timer was just going off, Tony. So that was like your internal timer is amazing. Go ahead, Matthew.
Okay, Nathan, mind if I answer why we can't see Everest from where we are? Okay, let me break this down for you, PhD, Tony. There is such a thing as visibility. You could check it, your weather app or whatever, and let me give you like personal, observational, testimonial information, okay? There's a mountain range. It's like it's like maybe 30 miles to the north of me. Sometimes I can see it. Sometimes I can't. Sometimes the blue sky is in front of the mountains. That's it. That's why we can't see Everest. We can't see forever.
So sometimes you can see Everest and sometimes you can't?
No, my point is, if there's mountains that are like kind of close to me, and there's days when they disappear, like visibility is a thing. Okay.
Yes. But why can't I see Mount Everest? You say
are you paying attention to what I just answered your question? I gave you personal observation.
Hold on one second. I'll give you 10 seconds, Matthew, to clarify your question, and then Tony, the floor is yours.
Yeah, to clarify, we can't see forever. We cannot see forever. The sky becomes opaque at a certain distance. Visibility is a thing. And like I just said, there's close by mountains that sometimes the blue sky is in front of, and I cannot see. That's it.
Over to you, Tony.
Even if I accept this argument, if I fly up into a plane where there is no pollution, where I'm above the cloud and where I'm above mist, I should be able to see Everest. The claim that pollution or clouds or smog or some other obstruction obstructs Everest is demonstrably false. If that were the case, we'd see it as soon as we got into a plane and got to 10,000 meters. We don't see that. The idea that you can only see a finite distance is false. You need to prove that. You're claiming that, and you're claiming that without any substantiation whatsoever. Where is your evidence that we can only see so far?
I just gave you my personal testimonial evidence.
I'm still talking, sir.
Ask me a question.
We can see stars that are a long way away
Another 10 seconds,
without obstruction.
Oh, so sorry. I was just saying you got another 10 seconds there before Matthew ejects. So go ahead there, Matthew. And
Oh, I just want to say, no matter how high you go up, there's going to be like gas and air. You know, like there's going to be like oxygen. You keep going up. There's going to be all kinds of atmospheric stuff going on. And not only is there that, but when I mean, I don't mean to sound weird, PhD Tony, but when things are far away, they look small. Have you figured that out into your flat Earth trash talk?
all right,
That
all
when
right.
things are far away, they're gonna look small. Like if I'm 100 feet away from you, dude, do you think I'm gonna be 6'3"? If I'm 100 feet away from you, I'm gonna look like an inch tall. Now, how big do you think Mount Everest should be? If it's what, like 10,000 miles away from you, do you think it's gonna be its maximum height? Dude, I'm
It's
sorry
going
to
to be
tell you, like.
it's going to be taller than anything between it and me. There's nothing obstructing it. And you'll climb, and especially if I'm at 10,000 meters, there's nothing obstructing it. There's nothing in the way. You'll claim that
It still gets small.
oxygen can obstruct vision.
1 second, Matthew.
Please demonstrate it. Where's your evidence?
So,
Before you guys start responding, Nathan, I will cede you the floor. But I just want to
Look at.
Hold on 1 sec, y'all. Hold on, Matt.
one
Hold on.
second there, guys. All right, so I'm just got you on mute there, Matthew. Before we carry into this, I do want to check with you guys. We've been going almost for what? It's an hour and 50 minutes now that I've had you. I do want to check to make sure that none of you have any time constraints, because I have no problem to let you guys continue with this discussion. But we've got 4 people here, everyone. If you're hanging out in the live chat, hit the like button. You know, this is a lot of discussion going around and a lot of effort getting put in here by the speakers. So does anybody have any time constraints? Speak now or forever hold your peace.
Yes, I need to go to bed.
You need to go to bed? All right. Well, you go to bed whenever you need to go to bed, and I will adjust for that. So just let me know. No problem. So I'll let you guys carry on with what you were discussing. I did just want to check in there. So no worries. We're going to keep tonight really chill. If you need to drop out, just send a message in the Zoom chat and carry on, fellas.
Yeah, and if there are, I don't know if there's any questions specifically for Tom or anything like that, but if there is and everything, and that you want to ask his, and then we could go back to discussion or anything like that. But I would want to say, Tony, I'd like you to consider, if you're looking at an object like Mount Everest, and it would be taller as far as its true shape and size and height than anything in between you and it. But if you have Everest very far away, it's going to have angular shrink. It's going to look small. And so you can have an object that's closer to you. You could have a mountain before that appears bigger because of its closer position to your eye. So your eye's angular resolution will resolve it bigger. And then there is also, if you go up in elevation and you're looking out, if you start to look down towards and tilt down toward what you're looking at, a small mountain that will appear smaller, you're going to look back down into those things like debris that can block your vision. Water vapor causes magnification, which will distort things. There's a vanishing point because we have the ground going up and the sky going down. And so they're competing for visual data in our eye, what our eye can take in. And so when the ground light has met the competition line of the ground light, when the skylight and the ground light have met each other's competition line, they have competed to each other to the furthest resolution we can see distance wise, and anything beyond that would be vanished, because you would only going up in elevation, you would push that back. And if we could go high enough up, we would be able to see Everest, I'm sure, from a high enough elevation, but we can't get there. Even NASA and all of them say we can't get past low Earth orbit, and all of those things are a problem to get high enough up. So you run into issues with that, which it supports an enclosed system. But if it's free space above us in outer space, we should get high enough up to just take a picture of the Earth and settle the thing, the whole discussion. But we can't.
Okay.
So anyway, there are multiple variables factored into why Everest would be hidden.
Okay, can you provide a single academic reference for anything that you just described? Or is it just garbled nonsense that you've heard from other flat earthers that you're reciting here as though it's meaningful?
No,
have you personally studied optics?
I've done just a little bit of stuff with like organic chemistry and refraction labs. But as far as like the magnification of the atmosphere, I haven't I don't think technically gotten into that. But there are like when they were talking about the horizon or the skyline that was seen from Michigan of Chicago, the weatherman had mentioned that it was a superior mirage, and then they had gotten scientists who are globe tenants. They had said that the atmosphere does act like a lens because of the water vapor, and so it does cause things to that are closer to you to bloom up in your vision and to look bigger. And so if something is looking bigger of your angular resolution, it's going to crowd out other things, and so that also will further restrict what you're able to take in through your
Okay, the bit about crowding out, I need a reference for. Show me the textbook or the scientific paper where this crowding out phenomenon is discussed and described.
Could I give you a demonstration?
No, I want a scientific paper describing and enumerating this option, because what you're describing is actually not physical reality.
Okay, I don't think I'll be able to meet that request right now because I don't have a paper on that specific topic.
Okay, my
So
suggestion to you is that you should actually, because I hear claims like this a lot, and they're generally made by flat earthers who actually don't have any formal training in optics and don't understand what they're talking about. And they might be well advised to actually get some training in some physics.
Okay.
I agree, and I do think that the people who had mentioned that water acts like a lens in the atmosphere and causes magnification, and causes optical phenomena, and mirages and illusions, I believe they had some form of educational background.
Yes, and did they tell you how often that happens? Is it a common thing or is it an uncommon thing?
It varies by the humidity in the air, the temperature.
It's yes, I know what
Weather-dependent.
the functional variables are. I'm asking if it happens a lot or if it happens rarely. If it was on the news, that is because it doesn't happen very often. So unusual conditions led to this phenomenon being observable on this particular day, and they got experts in to explain why it happened. That does not mean that you can invoke it to explain commonplace observations, because it's a very unusual phenomenon, and I know exactly how it arises, but it's not a commonplace event. And so you appealing to it as though it can explain all of our observations all the time is not valid. Do you understand that?
I understand, but I think it is valid because it's understood that there are multiple conditions that determine how far we can see on any given day under any given set of conditions. And so let's say if we're in Michigan, that the furthest we're allowed to see with the clearest conditions that allow us to see the furthest are something that allows us to see the Chicago skyline, which should be hidden by a pretty substantial amount of curve. But I would wager that on average, the weather of the area would tend to put the visibility termination line somewhere between Michigan and the water, so that it actually prevents you from seeing Chicago. And even if you have fog around you, you're going to have your field of view limited to like 30, 40 feet. So I would say it's somewhere between those events that keep it very close and near and very distant. And most of the time, the conditions will put you 5 miles out or 10 or 20 miles out. But then that would, if we want to take that to the Eratosthenes thing, or not the Eratosthenes thing, but the boats going over the horizon at 3 miles, how do we determine on what day, on what conditions, the actual limit of how far away we're seeing something go over it? The distance to how far out we can see changes,
10
so that our
seconds.
value would change. And so I think that
Can you Google visible termination line for me, because you used that term as though it was technical jargon. Can you Google that for me and see how meaningless it is? Because it doesn't refer to anything that is real.
And while you do that, I'll just remind everybody that approximately, I'm going to say if you guys got more thoughts to get out, that's all cool. But approximately 5 to 10 minutes, we should start engaging with the audience a bit with
I
the
just need to
Q&A.
duck off to go to the bathroom. Sorry to interrupt.
That's fine. Yeah, if you need to use the washroom. TJump, you were shaking your head earlier, when you were listening to some of what Nathan was saying. Did you have any thoughts over there?
I think it would be faster to list the coherent things he said than the stupid things.
All right, Matthew, you're making faces over there. We have to. Tony is not here to engage right now, so I know that you just said a big part of your piece there, Nathan. So I'll cede the floor over to you, Matthew, and see if we can get some engagement back and forth between you and TJump while we wait for Tony. And like I said, everybody, get your super chats in. They'll be priority read to all the debaters here. So go ahead, Matthew.
Oh well,
Hey,
since the
quick,
dude
Matt,
is
before you jump,
oh sorry.
could I just have like 10 seconds to explain why I use the term like visual termination line?
Okay, 10 seconds, sure.
So I use that word just to try to convey a meaning of us having a vanishing point due to our perspective of the ground and sky colliding. So I was just trying to use terminology that would convey an image to be able to follow along. But there might be a different technicality for the word or anything like that. But I do apologize
to
for
me,
the wording.
To me, it sounded like you're appealing to something that is absolutely not demonstrated to exist to explain something that you can't demonstrate using physics. That's what it sounded like to me.
Any thoughts there?
Sorry. And actually, I'd like to say something else. This is why I don't like using optical evidence. This is why I prefer using length scales, submarine cables, flight paths, navigation, earthquakes, atmospheric waves, because whenever you get into these discussions about what you should or shouldn't see, it always boils down to fairy tales about optics being different from we understand it to be. The limit of refraction or Rayleigh's criterion or whatever magical phenomenon people want to appeal to. And it's why I prefer to stick away from these blurry out of focus photos and actually stick with something that is measurable and repeatable.
All right.
That was fascinating.
I think this might be a good
Agreed.
time, everybody, to move into our Q&A. We got lots of questions that are coming in. And if you're hanging out in the live chat right now and you want your question to be asked, get it in there as a super chat, and that will ensure that we read it before the end of our debate. So let's get into it, everybody. And once again, smash that like button as if it owes you money. Ambient guitar music says, question for TJump. Why does Polaris never move?
You mean in the sky? It does. It's not completely stable.
Any other thoughts on the panel there, or do we want to move on?
Yeah, we've got abundant observational evidence that it moves. We've got abundant observational evidence for a precession at the equinoxes. The equinoxes are observed to precess by about 50 arc seconds every year. So the claim that the stars are stationary is just a result of not actually looking with sufficient precision at the data sets involved.
All right, let's carry on. Unless you got any thoughts on the other side.
Matt, can I take this?
Yeah, go for it. Because I was listening, but you could go for it.
Okay, so with 26,000 years is claimed to make a 360-degree circle. And so Polaris, we'll say, has been the pole star for about 500 years, which would be about, we'll just say it's about 7 degrees of arc in that sky. So it took 500 years to get that 7 degrees. And the claim is that only within the last, or in the next 100 years, will we approach the pinnacle where Polaris is the most aligned the axis of our rotation. So we're not even at the peak of Polaris being the pole star. So that means in 500 years, it covered 6.99 degrees of the arc swing. And then in the last 100 years, it's going to cover a very small portion of the sky. and aligning itself. So that would turn this arc that casts over 2,600 years, and it would essentially make a sky path that looks something like this, where this part here is taking a lot of time, and this narrowing here, and then this can get covered. This swath can get covered very quickly, but it's claimed to be a gradual swinging of the arc through the sky.
Do you know what, according to the zodiac, according to astrology, what star sign should you see at dawn on the spring equinox?
I don't follow star signs.
Okay, so it would be it would be Aries is supposed to be there. But if you get up in the morning and you actually have a look, you won't see Aries, because Aries isn't there. It's Pisces, because the stars have changed because of precession since the zodiac was developed. Also, if you bother to get up and actually observe stars rather than opining about them without any observational evidence, you will notice that Scorpio is barely in the zodiacal belt anymore. Its place has been largely taken by the constellation Ophiuchus. So the claim that there is no precession is falsified instantly by the observed precession of the zodiac since Hipparchus compiled his star charts, and since the Chaldeans compiled their star charts before him.
I would refute that with the Chaldeans being a flat earth culture, and that there are cycles to the sky and cycles within those cycles. And so some cycles will take longer because the sun's grand hierarchy of cycles takes a different time than the stars. Over time, we could expect that the sun will go through different zodiac signs
so you do concede that the zodiac does change, and that the and that the position of stars changes.
Hey, I would throw it out there that no, Polaris is not moving, because there's megalithic structures that line up with Orion, and if the stars were tilting, or if some other bigger, like 30,000 year cycle is taking place, that would not line perfectly with the pyramids, and Polaris would not be exactly above the North Pole. And to answer further questions about Polaris, it looks like it's turning. It's in one spot turning on. I think it's the 1 degree. I'm not sure how to describe it. It's like it's just turning in its spot. It's not moving anywhere. You know, I don't believe that stuff where they say like it's going to shift to a different pole star, because if it's not moving now, and it wasn't moving 10 years ago, and it wasn't some other place 100 years ago, probably like in a year and in 10 years and 100 years from now, probably going to still be in the same place. Hopefully we're all alive to, know, right? Hope we all live long time to see that pole star stay put for another couple thousand years.
So you don't care what the high precision observational data is, you're just not going to believe it.
No, I look at the stars. I track what's going on. I compare it to what I've seen throughout my life, and I see that there's no tilt, which should happen every year. I mean, tilt, that's not something that would take 100 years to see if it happens or not. Allegedly, tilt is the reason we have seasons on the globe Earth. But the sky is not tilting.
Your inability to see tilt is largely a product of your inability to properly understand how it would be detected. But the tilt that we see is the angle between the plane of the ecliptic and the celestial equator. Are you claiming that the sun is always over the equator?
No, I'm claiming that
so the path of the sun is at an angle to the equator, right?
Please don't interrupt me, PhD Tony.
I asked you a yes or no question.
No, what I'm saying is
that the tilt we see
is non-existent. Okay. What was the question again? Because that's what I mean.
We can. This is the first question, guys. So keep those questions coming in. Go ahead, Tony.
What
is the plane followed by the sun always over the equator?
Is the plane followed by the sun always above the equator? You mean the path the sun takes? Are you talking about the Tropic of Cancer? Yes.
No.
In summer, The summer solstice, that's when it's like at the edge of the Tropic of Cancer. Then when it's
So is
winter,
the Tropic of Cancer the
please don't
equator?
interrupt me. When the
Is
sun's
the Tropic
path
of
is
Cancer the
furthest,
equator?
it's called the Tropic of Capricorn. That's when we get the winter because the sun, the
Okay,
path,
10 seconds.
the path of the sun expands and contracts throughout the year. That's how we have seasons. There is no tilt.
Okay,
So
Tony
this
asked
was-
a
that
clarifying.
was-
Hold on
that
there,
was-
Nathan.
so-
Tony asked a clarifying question. Over to you, Tony.
Okay, so the Tropic of Capricorn and the Tropic of Cancer are not the equator. Therefore,
Yes.
the sun is not always over the equator, right? That was my question. Is the sun always over the equator?
You're right.
No,
The
it
sun
isn't.
is not always over the equator. You're right.
Okay, so the angle that the path of the sun makes with the equator is the ecliptic angle. That's the obliquity. Saying that the obliquity is 0 would require that the sun is over the equator. So you're saying that something that we observe isn't real.
No, I'm saying the globe theory is lying about what's happening in reality. I'm saying, yeah,
How so?
like you just said. I mean, what do you mean about the sun? You just said you thought the sun would always be over the equator. No,
No.
I just explained to you. The sun has a
No, I
path over
didn't.
the earth, right?
Don't
The
lie
sun has
about
a
me.
path over the earth. It goes from the Tropic of Cancer in the summer, then it goes over the equator, and then it goes down to the Tropic of Capricorn, giving us winter. Then
Look,
it comes
Ryan,
back. Then
I'm
it comes
going to
back.
ask that he
path
be cut off here
contracts
because
and
he's lying
expands.
about what I said.
No, I'm not. I'm listening
Okay.
to you, man.
I know
Love you,
you wanna-
Tony. I love you.
All right, I know you want to jump in here and there, Nathan, but let's move on to the next question there, guys, because we got lots of questions, and I'm sure eventually we'll come full circle. We always do. Malavaya, glad to see you're hanging out there, buddy. You know, a big critic of mine originally, but we grew to love each other, and I really appreciate. He's an honest guy, so that's cool. Personal incredulity, poisoning the well, ad hoc. How many more fallacies this dude gonna unleash in his opening? Oh, he's still spicy. So Malavaya, I think he, I'm not sure he's coming after there. So he says, poisoning the well, ad hom. How many more fallacies is this guy gonna unleash in his opening? Who do we think that's for? Malavaya, you didn't really specify. Let's continue on. Malavaya goes on to clarify $5. Thank you so much, Malavaya, and keep the super chats coming in, guys. We really appreciate this to carry the conversation forward and get those questions in. Tectonic plates cannot work on a flat Earth. Earthquakes cannot work on a flat Earth because a flat Earth being caused by tectonic plates. Stop your nonsense already. Okay, I think that clarifies the first question. So he accused you guys of poisoning the well, and then is saying that your explanation for the tectonic plates is not accurate. So, thoughts on that there, Nathan and Matthew?
You want to go first?
Yeah, I'll just real quick throw this out, and then so with the terminology itself, plate, it's kind of like airplane. A plate itself is a flat surface. There are plateaus, abyssal plains. There are these flat features, flat referenced features throughout tectonics. They are something in the ground. There are structures, and if there's a jostling of them, maybe if something hits it from this side and then causes it to wiggle, you're going to measure something on the other side of the plate, and that could send something through. Yeah, I think that the term plate itself, it's a piecing together of these sheets as far as at a certain elevation, and they're moving around depending on how much oil lubricant we take out from within the earth and everything.
Good one. May I add just a little bit? Okay, I live in Southern California.
Yeah,
we got earthquakes all the time. Okay, all the time. The street setup, it's perfectly like north, south, east, west. If you look on a map of like where I live, they're all lined up north, south, east, west. So if there was plate tectonics shifting around, there would not be that alignment. And I would just tell you guys, yeah, look at my area. It's like Fullerton, Anaheim, Buena Park. The streets are all like perfectly like miles. They're like squares, and they align north, south, east, west. So that's proof that there's no plate tectonic shifting going on. there are earthquakes. There's stuff happening beneath us. There's geothermal activity. Like what makes lava and all that. I mean, I have my own personal opinion that beneath us is hell. So there could be all kinds of weird stuff going on below, but rightly so above us. If there's hell beneath us, that means heaven's above us. There's all kinds of like electricity going on in the sky, and it's amazing. It's beautiful what the Creator did and where He put us. Thank God.
And with earthquakes too, there are events and things that happen at faults and where plates meet and merge. There might be, I think it's like subduction and things that can happen, convection and everything that can happen with those plates and how they interact with each other at those faults.
All right, over to you, Tony.
May I say something here?
Yeah, over to you.
Okay. The naivety of the discussion was transparent in the sense that you have not done any calculations, for instance, of how much material is being produced at the mid-ocean ridges or how much material is being subducted. We have done those calculations based on the length of those features on a globe Earth, and they match. So as much material is being produced as it is being subducted, which leads to equilibrium in the geometry of the plates. The claim that plates do not slide past one another, as was adduced just a little while ago, I'd like to share my screen again.
I don't think Ryan's there right now, or is he?
Okay.
Just play it. Let's watch it.
Yeah.
We're cordial.
Just a second. This is an image taken from the Alaska earthquake of 1969, where a school was ripped in half.
Landslide?
No, an earthquake.
Yeah, it looks like it just slid.
The
whole Earth.
Yes, but it was actually an earthquake.
Where the Earth ripped open. That looks like a landslide. Cool
yes,
pic, though.
It said that it was an earthquake. You can look at the Anchorage earthquake.
There's earthquakes. I agree with you 100%.
Stop interrupting.
Sorry. Apologies. Love you.
Okay, so it doesn't matter what data you see. You're always going to explain it away as somehow fake, or somehow it's not what it appears to be, or somehow magically the Earth is flat regardless of what you see.
Dude, are you telling me that picture is your proof for plate tectonic shift? Is like a building that looks like there was an earthquake and a landslide?
It looks like it was ripped in half by motion of the plate. We have thousands of examples of faults, shear faults, that have ripped laterally, and then one of them has moved vertically. We've got lots.
But that doesn't mean the whole Earth is that. There could be things happening, yes.
But your claim was that nobody claims that these things happen everywhere. They happen at plate boundaries. So the fact that they happen around plate boundaries.
Yeah, my claim is I live in an area where there's earthquakes all the time.
And so you're an expert on earthquakes.
No, we have mudslides.
Was that school at a plate boundary?
Yes.
That was on a plate boundary. Okay. Yes. One thing I will say and I think it's very important to note this, I think it is worth noting that we do need more people going to school for trades and learning how to make infrastructure that can withstand earthquakes. I think that would be good for everybody.
So good.
So that's
just throwing that out there.
Right.
But that's easier said than done for shallow earthquakes. So in Japan, there's a lot of work that's being done on earthquake-proofing buildings and sky rises, but they can do that because the earthquakes are reasonably deep. Whereas along the coast of Alaska and along the coast of California, they've got very shallow events, and there's a lot more vertical earth motion because they're not having to lift up as much earth. But the idea that because you live in California, that makes you more of an expert on earthquakes than seismologists and geophysicists is absolute nonsense. No, it's drivel. Don't allow him to respond to that. It's fatuous gibberish.
Well, we are going to have to move on, everybody, because we have all kinds of questions coming in. So Ameridon says, if it is true that the Earth is flat, then why is it the case that we know for a fact items weigh about 1% less at the equator compared to the poles?
So the Elias effect shows that there is an influence of the sky above us on matter on this Earth. If you look at how pendulums are during an eclipse, which should have no bearing on what if a pendulum, a Foucault pendulum, for example, is exclusive, only motion derived from that is due to the supposed rotation of the Earth. The aligning of celestial bodies that has a negligible amount of gravitational influence, especially considering the results that are get during the Elias effect, you can get pendulums that will swing differently. And so now if you look at objects that were weighing on the Earth, if you look up at the sky and look at a time lapse, you're going to see stars that are north or south of the equator appear to turn almost into a point because they're getting smaller and smaller, the circles. So you're getting more angular turn over less distance. So there's going to be more angular motion imparted into objects or influence imparted into objects. Whereas if you're at the equator, it's going to go straight as it influences and imparts into the object. And so that can fluctuate. If you have something in a fluid, it can weigh differently depending on how it's traveling and the medium that it's in and everything. So the direction of the flow of the fluid flow could alter and shift.
Where is your observational evidence? Can you present any observational evidence for this?
So they weigh objects and they weigh differently depending on where they're weighed, and then we can tell that there is an influence of phenomena in the sky that affects how things behave on the Earth because of the Elias effect.
You're not doing what I asked for. I asked for evidence, and you're just repeating yourself. What is your evidence for what you are claiming?
All right, last 20 seconds there for you, Nathan. Let's carry on with the questions.
Yeah. So if I am going to if I put water a scale or something that can detect pressure in water and I push straight at it, it's going to get more of a more blunt pressure reading than if something is arcing across it. It's going to have less direct initial impact, and then the reading difference the difference in readings would be there because you have a whole force hitting something at once or the very tip of an arc, and then more would crash into it as the rest of the arc catches up to hitting that pressure plate.
All right, that was
that evidence?
So that
explanation.
That one was for Nathan and Matthew, so we're going to carry on from there. Kango44, thank you so much for hanging out in the live chat and your super chats. We appreciate everybody who has already asked their questions. Let's carry on. Mr. Beast spent 50 hours in Antarctica and filmed the 24-hour sun. He was not stopped by the army. He also did not see a huge ice wall. Matthew is having some thoughts there. Go ahead, Matthew.
Okay, really quick. Let me get this one, Nathan, about the 24-hour sun video. Okay, in Antarctica, I saw it, right? I saw a couple of them that did look like total fake CGI. Honest, I'll say it. The shadows weren't moving. Okay, but I saw one, and I thought to myself, what if this is just the North Pole, and they just flipped it, like mirrored it? So I'm like, yeah, obviously that's one thing. But in today's day and age, listen, they can make realistic videos of Taylor Swift performing fellatio on President Trump. So, I mean, come on. Right? Let's all go down, open up Antarctica. Let's go. Let's all go. Let's get those.
It's
ships.
already
Let's
open. That's how Mr. Beast got there. It's open. Anybody can go there. Anybody can go buy a
Mr.
ticket.
Beast. Hey, you know what the number of the beast is? TJump?
Any person can go there.
666.
That's not a real number. That's a
Hold on.
As we confirmed, it is a great Iron Maiden album. Let's continue on to the next question that Kango asked. Kango44. In a flat Earth, Antarctica goes all the way around the disk. So from anywhere on Earth, you could travel in any direction, and get there. Why would you have to travel south to get to Antarctica?
So when you're considering the way that you would travel, like as far as cardinal directions go on a flat Earth, you have to consider what the model is claiming. So if you look at a flat Earth map like what Matthew is showing here, north, if you were looking at a compass, which compasses always point to north, despite there supposing to be a south pole, it will point north, and then south is anything directly 180 degrees diametrically opposed to north. So that would mean if you have a compass in your hand and it's pointing to the north, you are going to turn 180 degrees so that the compass is pointing directly at you, and you travel in that direction. You will reach Antarctica, because both models claim, according to our magnetic declination and the way that our compasses work and that we navigate, south is away from north on both models. Circumnavigation is east and west, and that's possible. You make circles on the above the circle of a flat Earth or around the circle of a sphere Earth, but east to west circumnavigation is the only way. And on both models, they claim the same thing. North is towards the way the compass points, and if you go 180 degrees, you're south.
All right. I think we can move on from there if that's all right with everybody.
Mm-hmm.
All right, no objections over here
Well,
on the panel.
We can have compasses that actually do point to the South Pole. You can do that.
Yeah.
Go ahead.
Actually, I was going to mention that in the southern hemisphere, our compasses use the southern magnetic pole to point, but they're just going to say that that's bullshit and not agree. So what's the point? Let's move on.
Okay.
Is that
Let's carry on.
factoring in declination? I'll look into that. I've not heard that, but that's not having declination make it appear to point at a south pole. That's actual. It's homed in
Yes.
on a magnetic south pole. Okay.
All right. Let us do carry on, because we do have quite a few questions to get through. Dr. Dino says, geology is great for showing the Earth is a globe. Earthquakes release P and S waves. P waves go through liquids, S don't. Measuring them lets us see an outline of the liquid outer core. The way the P waves refract through the core shows us there's a solid core at the center. Geo rules. Thank you, Dr. Dino. Love you, buddy. Thoughts panel.
Yeah,
Is that-
so that's something that I didn't dwell on in my presentation, but there's a thing called the P wave shadow zone, where the P waves slow down. So that if you remember that presentation I was showing, can I show it again, or am I pushing the friendship?
Well, I was gonna say it's quite a bit of screen sharing, but yeah, if you can keep it to like 30 seconds, that's cool. Let's see what you got there.
Okay. Sorry. Yeah. Okay.
No problems. Don't worry.
All right. So this is the area. So
There we go.
okay.
Let's
So
clear it up.
sorry, this is the wrong presentation, but whatever. As you converge in, the P waves slow down, and so you get this area here at about 1200 seconds, so 20 minutes afterwards. You can see that there are no blue lines, no blue circles, and it keeps on staying that way for a while. The P waves don't arrive. That P wave and then they start arriving after a while. That is because P waves travel more slowly through fluid than they do through everything else. So here you're finally getting the waves coming through the liquid core. So the fact that this P wave shadow zone, which always occurs at the same distance from whichever earthquake you've got, is always caused by, so it tells us, again, as TJump was saying, we've got thousands and thousands of earthquakes, we've got thousands and thousands of observations. They all behave like this. They've all got this P wave shadows.
All right. Well, thank you for that. Any other thoughts there? If we can keep it to 30 seconds before we move on to the next question.
Just
Go ahead,
really
Matthew.
quick, I thought they're all talking about the core of the Earth. It's like, oh, it's solid. No, it's liquid. It's like, how can we get down there and actually verify these fairy tale stories about what's going on so far down there? What is it that scientists can make all these guesses and we just take it as the truth? And people can't get down there to the core of the Earth, thousands of miles. Guesses. Guesses, assumptions, fairy tales.
It's called
That's it.
basic
Okay,
inferences.
Matthew, have you ever had a child?
Oh, no, not yet.
Okay, are you aware of the concept of ultrasound on pregnant women?
Yeah, you're talking about when they put the
Okay,
device
that's
Testing,
exactly the
testing.
same technology,
right
mate.
to the world.
It's exactly
right?
the same technology. It's
That's
sound
not
waves
thousands of miles
traveling
away.
through a
Oh
body.
my God.
Dude,
Okay.
dude, that's a bad example because the baby is right there, not thousands of miles away.
If the
It's
radio
the
waves
same
work at 1
technology,
inch,
mate.
All right,
It
guys, hold
works
on.
exactly the same way.
Let's let T jump in because he hasn't, like I said, he's not had much of the floor here. So T jump, go ahead.
so if waves can be used to measure thing at 1 inch, they can also work at a mile and 10 miles. The same science works at every distance. That's why we can see like stars and stuff. Waves, like
Well, we
light
can see
waves.
stars. You're talking about scanning the Earth, scanning thousands
Yeah,
of
that's great.
miles into the right. I don't mean to
Yeah.
interrupt you, but that's what I'm hearing. That's
Yes.
what I don't believe. I don't believe these
do
fairy
waves
tales and
stop
stuff
working?
that
Do
you
waves
want me
stop
to
working?
believe something. That's the
Stop,
problem.
Hold on,
stop,
Matthew.
do
Matthew, just 1 second.
waves stop working if you just go a farther distance? Do waves just suddenly stop being
depends.
waves?
It depends on what types of waves, I guess. I don't know. What waves are you talking about? Radio waves? Television? Like, because what happens
All
if
of
the
the
television
waves.
signal gets
As
bad,
long
right?
as
Say
there's
it's
a
from
medium
behind a
for the
mountain.
wave to propagate through without obstruction, I think it would go until it hits a boundary of the medium.
That sounds
Yeah,
pretty
like
good.
if I'm
That
in a
sounds
car
pretty good.
driving
So
and I'm
if
hearing the radio,
All right, hold
right?
on,
But I
Matthew.
go in a tunnel.
Matthew. One
stop,
second,
stop.
please. Let's let T jump in here just for a second. Like I said,
Pitch. I don't. What is your name? Pitch.
his name's Nathan.
Yeah,
Nathan.
it's
Nathan is
either-
correct.
yeah.
As long as there's a medium for the wave to propagate through, it'll continue to go and then bounce back with signals. Guess what? The Earth is a medium. It's a big rock. Stuff can travel through it. So if we send a radio wave or vibrations through it, it'll continue to flow through it till it hits something and bounces back. So just like the example of a baby, if the wave goes through it and bounces back, we'll get a signal, just like it would for the Earth, unless there's like a big gap
For
there.
instance,
Yeah,
for
like I
instance,
just said, the baby's a lot closer than thousands of miles away. And like I
Alright.
said, if you're in a car listening to a radio and you go into a tunnel, you're not going to be able to really get it too well. There's so many things that could stop it. And you want me to believe that you can,
10
these
seconds.
waves, right? They're going to penetrate thousands of miles to a place no one can go to or verify. You want me to believe your equations.
well,
I reject
it. Over to
we
Tony.
sense that we
Sorry.
sense the earthquakes on the far side of the earth, don't we? So
Do you have?
I
Yeah, you
showed an
probably have
equator.
machines there.
Matthew, it's Tony's
I
time.
showed an earthquake. Okay, I'm still talking. I showed an earthquake at Macquarie Island. The waves traveled all the way to the North Pole. And indeed, on the flat Earth, they traveled all the way to the far side of the flat Earth. So you're claiming that, well, the waves don't travel that far. Demonstrably, they do.
That's the surface.
Well, they travel through the Earth, right? We can don't worry your pretty little head about it, I guess.
Well, thank you.
Well,
Love it.
let's suppose
You're
the
talking
world
about
is flat. Let's
surface.
just
That's
suppose
the
the world is flat for a minute.
surface.
Shush,
Just 1 second
shush.
there, Matthew. But
Suppose the world is flat. Earthquakes do
let's
happen.
ask the question.
There are vibrations, and the vibrations travel
Uh-huh.
from one end of the earth to the other, which means they necessarily travel that far. Even on a flat earth, they still travel that far,
On the surface.
which is still far enough.
Yes.
Oh, so you admit you're wrong?
But no, there could be machines that could feel that. What's my point? What machines are down in the center of the earth that you could verify the signals?
This might be a good time to move on, guys. We got lots more questions. LJ coming in. LJ, you got a nice new fresh picture there looking fly, buddy. In the globe model, you have to believe when you watch the sunset, you are on a ball falling over backwards faster than the speed of sound. Do you feel it? Well, that one is for Tony and TJump. Let's keep these to 1 minute and we can get you guys out of here in a good time.
No, you don't, but you only feel accelerations, and the acceleration involved with the Earth's rotation is smaller than your vestibular system's ability to detect.
All right. Any other thoughts there, TJump, before we move on?
Potato.
All right. Kango 44. Can Nathan and Matthew please give us their PhD credentials? Ooh, the industries they work in that use applied sciences and the papers they have published.
Hey,
Kango is coming right for you.
Hey, my PhD credentials. Hey, I'm keeping Tony on his toes pretty good. He's a PhD, isn't he?
No,
That's
you are
my
not.
PhD
You are not.
credentials. We're banging it.
Okay.
Me, I'm not a PhD.
Feel free to
Banging
use
with a
me as a
PhD pretty
reference.
good, huh?
Feel free to use me as a reference for your intellectual capacities and see how well that works out for you.
I'll show him the video of this debate and say,
This
this guy's a PhD, ladies and gentlemen. A PhD level, like a doctor. He's the man.
All right. This was already kind of a catty question.
PhD is well earned, difficult to attain. That stuff is legitimate. And for credentials, I had to change my major because of something that I went in school with something I got into with the school system and an inaccuracy in what we teach. That it's more based about evolution, but it was obstructing my ability to carry my nutritional cardiology degree forward. And I could talk about that, but yeah, no credentials right now. And you don't have to have a credential to be interested or to want to learn or to talk about topics. And especially if you have someone like Tony who is able to explain things very well, it makes it a lot. Learning becomes an easier process. But yeah, those PhDs are definitely earned.
All right. Well, thank you so much, Nathan. And
You're very kind. Thank you.
yeah, that's very nice of you. And let's carry on, guys. LJ, why don't we have real non-CGI videos of space?
We do.
You want to answer that one, TJump?
We do.
Nice and short and sweet. Tony, why don't we have real non-CGI videos of space? Any thoughts there, or do you want to carry on?
We do. It's just the reflexive dismissal of any evidence that runs counter to their belief system as being false traps them. If they see something, they instantly conclude that it must be false, that it must not be what people say it is. And it's kind of sad to see people fall into such paranoid holes.
It's called the nuh-uh argument.
Hey, can I real quick just share my screen?
I was gonna say, I know the natural human inclination is to want to respond. We do have more questions.
If I could just have like maybe 10, 15 seconds.
When I said it was natural, it was it's warranted. They'll go ahead. If that's how you feel, let's do it. 20 seconds, 30 seconds if you can.
I think it bears some ability to show the credibility of NASA and the images that were given. So this here should be my screen. So this is something I showed. These are images supposed to be of the same Earth, the same data set. So you have the continental United States taking up about an eighth of the entire globe, and then over here you have it taking up about a 16th. So it's about half the size. And then you can get into things as well, like this is Robert Simmons who talks about it's Photoshop, but it has to be. And then this is actually part of his data set where you can see that there are these gaps in the data where they have to actually admit that they stitch it together, they paint it together. And then I had showed it briefly in my intro, but you have the duplicate cloud formations somewhere in here. And so, right here. So you do have these things where you get these anomalies that might not be there. Clouds don't have the exact same shape in several positions. So just something to consider about the validity.
If it was CG, why would they have to stitch it together? They could just make a whole system all like interestingly new shapes. If it was CG, why do they stitch it together if it's CG?
It's just easier to copy Command Z. There's artistry involved. So you hit copy and paste a bunch and duplicate the clouds.
Can I ask you to go back to your first image, please, Nathan?
Yeah. Sure, let's reshare that if you don't mind.
Yeah, no problem.
Go ahead, Tony, if you have some thoughts.
Okay, one of the first exercises I had to do as a research associate was map projections. So I had to make maps of features on the Earth, and this particular feature here is a common map projection. You get this by changing the observer height. That's all that is. There's no fakery here. No, the size that North America takes up depends on how close you are. It's like if I put my hand close, it looks big. If I pull it away, it looks small. There's nothing nefarious about that. It's just that one is taken from closer to the Earth with a different camera than the other one. The properties of the camera and distance to the Earth are the two factors that explain this, not conspiracy.
So
But
I
that's all
would
wanted to say.
ask to that when you give the example of your hand, it's the
Let them the
whole
screen
of your
share.
hand. If you drew like a smiley face on your finger or something, all of your hand is gonna have its apparent size shrink and the smiley face in your hand. But
All I
those
can
are
tell you, all I can tell you, Nathan, is that I've done these map projections. I've mapped what this looks like from different altitudes, and this is an accurate idea of what it looks like. And if you don't think that it's an accurate idea of what it looks like from different altitudes, then I would suggest you haven't investigated it. Because
why
that's
does the
exactly what I
landmass
expect.
So why does the landmass shrink but not the water around it as well, like the whole totality?
That's just a visual. You're looking at an object where they've both been scaled to be the same size. In fact, in the camera, they wouldn't be the same size. One would be smaller than the other, because, as you say, the object would be further away. So you're not comparing apples to apples or oranges to oranges here. These are two
Wouldn't the
different
whole
images.
Earth shrink, not just parts of land?
Last that's for you, Tony. And we're moving on.
All I can say is that applying the laws of perspective to the Earth, that's what you see from different altitudes. I can't explain it any more clearly than that. And you trying to find holes why that shouldn't happen, that image that you showed is exactly what I saw when I did this exercise. And I'm telling you what I did, what I saw from these things, and I think you need to stop I think you need to look into that in order to be better equipped to analyze it.
All right, let's ask the next question. Kango 44, measure Earth curve. With total stations, you can do it in an afternoon. Measure the rotation of the Earth with a pendulum or a gyro takes an afternoon. Do TJump's ham radio experiment. Can do it in a weekend. So Kango is basically saying that you can do these experiments. They're very easy is, I think, the bottom line of what he's trying to communicate there. 1 minute. We'll try to keep this one, Nathan and Matthew.
Oh, I'm interested in that ham radio test. I mean, yeah, you guys are smarter than me, right? But like, don't they bounce radio waves off the ionosphere? I mean, are you trying to tell me that the moon is within the Earth's ionosphere? I have heard some things from like science people saying that the moon might be in Earth's atmosphere, but is that what you did? Like you shot ham radio waves and bounced off the moon, and other people did the same thing to corroborate your data?
Yes.
So how did your ham radio waves get through the ionosphere or the Van Allen radiation belts and successfully go right back to you?
Because different powers and wavelengths of radio waves can go different distances. Pretty simple. Like
Nice,
very
man.
basic, like 8th grade stuff.
Nice.
Also,
I didn't learn any of that. I didn't learn any of that in 8th grade. Didn't talk about that.
It also needs to be pointed out that not everything gets reflected from every surface. So you can have a half-silvered mirror that will allow some of the signal through and reflect only some of the signal. So your mental image is that the ionosphere is a perfect reflector, that it reflects 100% of the wave on impact. And I don't think that that's an accurate image.
How about the idea that maybe the moon is small and local and it's not 250,000 miles away? It's actually, a light that we see. Sometimes it appears in the clouds.
Yeah, that's
Do you
stupid.
think
there is an experiment called the Lunar Laser Ranging Experiment that bounces lasers off retroreflectors on the moon's surface.
Do you have a picture of these reflectors? Can we zoom in on it with the telescope and see these reflectors?
No, you can see them in some imagery from lunar probes.
That sounds.
Yeah, again, so there's evidence that doesn't agree with what you want to believe. So
No, the premise behind
no,
it.
Just one second, Matthew.
That's fine. let's move on to the
Matt,
next question.
let me close this one off real quick because
this was
there
for
is
you
a
guys. I
lunar-
noticed you
there-
came
there's
off
a-
mute, so go ahead there, Nathan.
there's a lunar range that we can try to do with the light that we send to the moon and receive a signal back that we are able to detect. And I think that we can estimate the distance of the moon based on how fast we take the speed of light and given the globe model. But we also have to consider that on a flat Earth, there would be different mediums like going through glass that would change the speed at which we receive the light back. And as far as detecting the curvature, I've talked to people who are work with geography, geology, and seismology, and they're geodesically involved, and they say it's actually very hard to determine curvature of the Earth over distances up to 100, 200 kilometers.
All right, next one coming in from Grover Reed says, I have a solution. How about all flat earthers put their money where their mouth is and pool their money together, build a rocket and take pictures of this flat earth? Problem solved.
Yeah, all I got to do is be a millionaire,
Agreed,
get all these
100%.
credentials, and get all these politicians in my pocket. Yeah, fairy tales.
You can go to the South Pole or the North Pole on your own. Doesn't take that much. You can do it.
Oh yeah.
Easy.
Oh
Someone
yeah.
send a
No
rocket
one
up
will
with a
stop you.
camera on it and just have it film the whole way live feed and have it go into space and show the sphericity of
Forget
the
space.
Earth.
Go to
It'd be-
Antarctica. Just
That's
go.
been-
If it
that's
wasn't
been
difficult to
done,
get past
Nathan.
low Earth orbit, but they have scheduled small steps that they want to take, the administrations and the government want to take to get us to these further away celestial bodies, but we're just not there yet because there's setback after setback after setback.
All right, last word to you, Tony, there, and then we're going to move on.
Okay, one, there has been footage of cameras strapped to rockets that have gone into orbit. Two, the Artemis probe did make it to an orbit around the moon, so the claim of low Earth orbit is just false. And finally, you don't even need to go to Antarctica. You can go to Argentina and measure the length of that railway track, or you can go to Australia and measure the length of that railway track. Either of those observations permanently debunk the possibility that the Earth is flat. If those track lengths are correct, you're just wrong.
All right, let's carry on. Tango 44. Sorry,
land...
we have to move on. I'm so sorry. We got all these questions, and I know TJump said earlier he has to go to bed, and he's
I'm going to bed.
carrying on. You're going to bed.
Peace out, guys. See you later.
They love you, TJump.
Yeah.
You're leaving now.
See you later, TJump.
Have a good one, Tom.
Thank you you so much. I appreciate
Having
it.
a good smooth.
Thank you for
buddy.
being here, and I had someone to help me keep my sanity in this one. Oh god.
Do you have
Goodbye.
sanity?
No.